So today we're going to go over the first derivative test, which can be used to find the relative and absolute extrema of a function. So what are relative and absolute extrema? Well, relative extrema consists of a minimum and a maximum. Likewise, absolute extrema also consist of a minimum and maximum. But where do they differ? Well, absolute or relative extrema exists where there's a point of inflection on a function, and that simply means a point where the function switches signs. So you'll notice here the signage of the function at that point goes from increasing, as you can clearly see here, to decreasing right afterwards. And that is what's known as a relative maximum. And hopefully that makes sense. You can clearly see that it's called relative because it's the maximum near its surrounding area. And if a function is increasing and then decreasing, well, that certain value where it switches is going to be higher than the values around it. Now, when the signage around a function goes from decreasing to increasing, or from negative to positive, such as here, that's what's known as a relative minimum. Here again, this would be a relative maximum, and this would be a minimum. Now, what's different with relative extrema than absolute extrema is that you can have multiple of both minimums and maximums. So here's a minimum, here's a maximum, here's another maximum, minimum, another minimum. So now let's go over absolute extrema. So absolute minimum is simply the point where you absolute minimum is simply the lowest y value on a certain interval on a function. And absolute maximum is the highest value. So how does this actually differ besides the number of extrema points? Well, on absolute extrema, you're going to first find the critical points, or I'll dive into that in a little bit. You're going to want to find the points of inflection, and you're going to compare those y values to the endpoint values. And whichever one is greatest will be the absolute maximum, and whichever one is least greatest will be the absolute minimum. Okay, so first let's go over relative extrema. Let's go a bit more in depth. To find the relative extrema of a function, let's say f of x, we're going to want to set f of x, or we're going to find the derivative of f of x, and then we're going to set it to 0. Now, why do we do this? Well, at any inflection point, there's going to be a parabola-like shape. Let's say it'll look like this, or also this. Here it's increasing, then decreasing, meaning f prime of x here is positive, and f prime of x here is negative. And so if we're going from positive to negative, then certainly there's an x value in between that is equal to 0, right? Surely there's a point where f prime of x is equal to 0, and that's what we're trying to find. We're trying to find f prime of x when it's equal to 0, because that's when it's changing, and that's when the relative extrema is going to occur. And this is what's known as a critical point. A critical point exists when f prime of x is equal to 0, or when f prime of x doesn't exist. Sorry, I should have stated earlier. You're going to want to set f prime of x to 0, and you're also going to want to find when that value doesn't exist, I should say. But then we're going to want to put our plot points, or we're going to plot our points on an organizer. I call it an organizer because I'm not quite sure what this is called. However, we're going to want to plot our x values here, and we're going to want to find our values to the right of this and to the left of this, our f prime values. So let's say here this is x plus 1, and let's say here this is x minus 1. You're going to want to find the sign value of f prime of -1, and you're going to want to find your sign value of f prime x plus 1. Now, why do we want to do this? Surely we've already gathered all the information we need, right? We just need to find when x prime is equal to 0. But that's not necessarily the case, or that doesn't necessarily mean there's a relative extrema. Let's say you have the function similar to this, right? Here, or somewhere along here, f prime of x is equal to 0, right? But it's obviously not an extrema because it keeps increasing afterwards. And we don't want to find instances where that happens. And that's why we need to find if the area or the function around it is increasing then decreasing, or vice versa, because that's when a relative extrema truly exists. And so if this is, let's say, positive, and this is negative, or the sign is at the very least, then that means that the function here on this interval is increasing because it's positive, right? When f prime of x is positive, then the function is increasing. And like I said earlier, f prime of x plus 1 is going to be negative. And when f prime of x is negative, that means the function is decreasing. And so if the function, let's graph this. If the function's increasing, leading up to x, and then decreasing thereafter, then that means this is going to be a relative maximum. Now, let's say that right here, before f of x, or any instance before f prime of x, if that happens to be negative, and any instance after f prime of x happens to be positive, then that means that you have a function that's decreasing and then increasing right before and after x. And that's what's known as a relative minimum. Okay, next up is absolute extrema, and it's pretty simple. As long as if you can remember how to find the relative extrema, you can find the absolute extrema. So what you need to do is you need to find the instances or the x values at which a relative extrema occurs on a function. Let's say you have a function like this, and it looks something like that. And let's say this here is 0, and this here is 4. What you're going to want to do is you're going to want to find the x values, or the y values of the critical point. I'm sorry, not the critical points. You're going to want to find the x values, the y values of the relative extrema. And you're going to want to compare that, like I said earlier, I believe, to the endpoints. Now, the highest value, the highest y value out of all of those is going to be your absolute maximum, and your lowest y value is going to be your absolute minimum. Okay, so let's go to the example problems now. Let's say we're trying to find the relative, just the relative extrema of this function. What we're going to want to do first is we're going to want to find the derivative, which in this case is 2x minus 8. And now we're going to want to set that to 0. Such that we have 2x minus 8 is equal to 0. And from here we can see, we can add the 8 over here, divided by 2. And it's clear that x is equal to 4. And 4 is our only critical point in this instance. So that's easy. It's going to be easy for us. So we have to find any value above 4, which let's just say 5. Now we have to find f prime of 5, see if it's increasing or decreasing, which is equal to 10 minus 8, which is 2. So it's increasing. Anywhere above 4, anywhere above f of 4 is increasing. Now let's find let's find f prime of 0, just a simple number below 4. So f prime of 0 is equal to 0 minus 8. So we have a negative 8, which is negative, meaning that it's decreasing at that interval. And since we have a function that's decreasing and then increasing at 4, then 4 is going to be a relative minimum. Now let's plug this into the initial equation. Let's find f of 4. which in this case is 16, minus 32 plus 4. So we end up with negative 12. So we have a relative minimum. Sorry, I'm all over the place. We have a relative minimum at f of at 4 and negative 12. Okay, so let's go over example problem 2. We're given a bounded interval. Or a bounded interval. So let's try to find the absolute extrema in this case. First thing is we're going to do is we're going to find f prime of x, which in this case is 3 over x minus 2x. And we're going to set this equal to 0, meaning we have 2x equals 3 over x. Now we can simplify this further still, find x squared. X squared is equal to 3 over 2, meaning x is equal to positive or negative root 3 over 2. So we found our critical points, possibly. However, you may notice that x can't equal negative root 3 over 2 because negative root 3 over 2 is not in the interval. This is only from 1 to 10. So we end up with x equals root 3 over 2. But if you'll recall from what I said earlier, we also need to find when f prime of x is undefined. So when is this function over here undefined? 3 over x minus 2 times x. Well, when x is equal to 0, of course, because 3 over 0 is undefined. However, we don't include that either because 0 is outside of the interval. So this is this right here is our only critical point, also known as a possible point of inflection in this case. So let's set up our organizer. Let's say this, of course, will be root 3 over 2. Or I should say root 3 over root 2. Let's say this right here is 1.1. We're going to want to find the signage at that point, if you will. And let's say this over here is 8. So don't worry, I've already plugged the values in for you. At 1.1, at f prime of 1.1, the function is going to be increasing. And at f prime of 8, the function is going to be decreasing. So what this means is that we have a relative maximum here. And that's not really important in this case, because we're trying to find absolute extrema. However, it does tell us that this critical point where f prime of x is equal to 0, it tells us that that is a point of inflection, meaning that's where the sign changes from positive to negative or from negative to positive. Okay, so we found our only point of inflection, f of root 3 over 2. Sorry, f of root 3 over root 2. And now we need to compare that to the endpoints in this case, which would be 1 and, f of 1 and f of 10. So we can see that f of 1 here, if we plug this into the initial equation, is equal to negative 1. So that could possibly be an absolute extrema. Now let's try this one over here, f of root 3 over 2. Don't worry, you don't have to do this by hand. I'm sure you could, but it's actually equal to negative 0.892. So it's impossible for this to be the relative minimum because it's higher than this one. But let's find f of 10, which again I already plugged in. You're welcome. It's negative 93.092. Okay, so this right here is our highest value. So this is going to be our absolute maximum, and this is going to be our absolute minimum. So we can say absolute max at root 3 over 2, negative 0.82. Absolute min at 10, negative 93.092. 0.092. Now, I didn't really dive into this earlier, so I thought I'd address it now. But if you have multiple points of inflection, meaning the sign changes at multiple instances, and you're trying to find the relative extrema, let's say this right here is 6, and this is 3. So obviously, you know, to find a value less than 3, the signage at a value less than 3, let's say 1. And you also know to find the signage at a value less than or greater than 6, let's say 7. But I don't think I told you earlier that you're also supposed to find the signage of a value in between, let's say at 5. So if this happens to be increasing, this is decreasing, and this is decreasing, then this means that at 3 there's going to be a relative minimum, and at 6 there's going to be a relative maximum. I don't think I stated that earlier. That's why I'm saying that now.